All right, we got some geometry action here. Section 1.2, segments, distance, and midpoint. There is less information to cover in this section than the previous, but there are more examples. Congruent segments. Segment OX is congruent to segment EN if OX is equal to EN. Now, there's a lot to talk about in this. So I'm going to say this following thing hundreds of times this year. Segments are congruent, lengths are equal. Segments are congruent, lengths are equal. So essentially what congruent segments are, like in layman's terms, it means two segments are the same size. Congruent in general means same size, same shape. So let's take this congruent segments definition and let's write it a little bit differently. We could write this as if, I almost forgot the elephant in the room. This little fella here is not a typo. If, with two F's, is a shorthand for if and only if, because mathematicians are that lazy. So I'll explain what that means in a moment. So one way we could read this, since it's if and only if segment OX is congruent to segment EN, then OX is the same length as EN. Since it's if or only if, we can take this and we can take the ideas and we can put them in reverse order. So I could say if the length of OX and EN are the same length, then segment OX and segment EN are congruent. Picture-wise, I'll get into picture-wise here. No, let's just get nuts. Let's get into picture-wise here. So here is segment OX. Here is segment EN. If I put one dash on each of those, it doesn't have to be one dash, but with the same number of dashes on them, it means that they are congruent, which means they're the same length. So if OX is 8 centimeters, EN's also 8 centimeters. Let's get deeper into this equal versus congruent, because this is a very subtle thing that is very important, and it's going to take a while for you to fully embrace this concept. I mean, it usually takes students a while. Equal versus congruent. So in this picture, we have segment ST, and I would like to be able to make a congruent statement. Is there another segment in this that is congruent to segment ST? ST has a length of 12. It's got 4 on this side and 8 on this side, that's 12. Is there any other segment on here that has 12 in length? There isn't that has named. Let's put an X here. We're going to cheat a little bit above that 2. So that means that XV, that segment, also has a length of 12. So we could say that segment ST is congruent to segment XV. If I wanted to use an equal sign for ST, this is the congruent symbol. If I wanted to say ST is equal to something, ST is referring to the length. Equal sign is referring to a number. So this is a number. What number is the length of ST equal to? Well, as we said at the beginning, it's equal to 12 in length. Let me repeat this again. Pictures are congruent. The numbers are equal. This is referring to the physical drawing, segment ST. This is referring to the length of the segment, segment ST. Equals is for numbers. Congruent is for pictures. You will hear me say that 1.9 billion times. Let's discuss this idea a little bit further. We are told in this picture, this is called a triangle. You don't have to know that at this point because we haven't formally discussed it. You probably know what a triangle is, but I'm not going to hold you accountable for that yet. This is saying the length of AB. It's saying the length of AB is 4 centimeters. So I can go to my picture, and in between A and B, I can put a 4, and I can put a centimeter, so I want to put the unit on. This says the length of BC is also 4 centimeters. Now, if I wanted to show in the picture that those two segments were congruent, I would put the same number of dashes on those segments. Choose any number you want, but if they're the same, it means they're congruent. What does congruent mean? It means they're the same length. So I could say that the length of AB is equal to the length of BC, which is 4. I could also say segment AB is congruent to segment BC. At the risk of causing you problems, here's what I cannot say. I cannot ever say that segment or the length of AB is congruent to something. This is a no-no. I cannot say that segment AB is equal to 4. This is also a no-no. A picture is equal to a number doesn't make any sense. Two numbers being the same size and same shape doesn't make sense either because a number isn't a real thing. It represents a count. Numbers are equal. Pictures are congruent. All right, I think I've beat that into your head, and I will continue to beat that in your head as the year progresses, as violently as I possibly can. Literally! Definition of midpoint. This is an awesome definition, and this is the first definition, second definition. I didn't finish my thought. This definition and this definition both enable us to read a problem and make an equation from it. And you're going to find that in geometry, making an equation from what the directions say is a very important thing. Definition of midpoint. If M is the midpoint of segment PQ, before I read any more of this, let's just draw that first part. Let's draw the situation. M is the midpoint of segment PQ. I don't know what midpoint means yet, but I do know what segment PQ is. It means that P is someplace, Q is someplace, and there is a bunch of points between them. That's segment PQ. Then M is the point between P and Q. So M is on here someplace. Let me try to represent M, and let me just show you by the power of modern technology. M is someplace between. Now it says that M is between P and Q such that, so it's not just any place between. It's there in a way that PM is the same distance as MQ, which we would say it's directly in the middle. Now, how do we show it's directly in the middle? By saying that segment MP is congruent to segment MQ. Our conclusion from this, PM is equal to MQ. This gives us a license that anytime the directions say, hey, this point is the midpoint of this point, we can make this equation every time. And you're going to need to make equations in this class, and we'll get to that when we get to the back of our notes, and you'll see what I'm talking about. Segment bisector. This is the definition. This is also going to get us to the point where we're going to be able to make equations from this using the congruent segment definition. A segment bisector, any segment, line, or plane that intersects a segment at its midpoint. So let's take segment AB, and let's say that M is the midpoint. If I draw this M is capital printed. It doesn't maybe look so. If I take a line or a plane or another segment and it goes through that midpoint, call that line L, then that means that line L bisects segment AB, goes through its midpoint. And what does that mean? Once we know that it goes through its midpoint, it means that we can make the equation AM is equal to MB, because that goes here to the definition of what a midpoint is. We'll get to that when we get to some real examples. Two more things. Midpoint in a coordinate plane. Midpoint essentially just means the average. Some symbols here you might not be familiar with, but I think that you'll like these symbols once you get over the fact that they're new symbols. The coordinates of the midpoint of a line segment whose endpoints have the coordinates x sub 1, y sub 1, and x sub 2, y sub 2. Let me just give you a visual of what that's talking about. We have an x and y axis, a Cartesian coordinate plane. This is the y-axis. Dyslexic. This is the x-axis. So let's say that we go to the right, an undisclosed amount of space, x1. We go up an undisclosed amount of space, y1. This ordered pair is x sub 1, y sub 1. It just means our first x and y pair. The second one, our second ordered pair, we go to the right so many units, who knows how many. We go up so many units. It's x sub 2, y sub 2. Sub means subscript, below, like a submarine's below. So if I connect those points and get a segment, this is going to give us the exact coordinates of where the midpoint is. The midpoint making this halfway between each of these things. And it's easy. You take and you add the x values together and divide it by 2, the average. You take the y values and add them together and divide it by 2, the average. So this here, this formula, a formula has an equal sign in the left and the right side. This M represents midpoint. It's equal to an ordered pair, x followed by y. This symbol here is epsilon. It means to add. So this simply means to add your x values, x sub 1, x sub 2. Sum the y values means that you add the y values together, y sub 1 and y sub 2. So you could write this formula as x sub 1 plus x sub 2 over 2, followed by y sub 1 plus y sub 2 over 2. But it's more writing. And if you haven't figured it out yet, mathematicians, and I'm no exception, we are lazy pieces of crap. We don't want to write more than we have to write. So we'd rather just leave her like this. Next, we have the distance formula, and then we'll do some examples. The distance between any 2 points with coordinates x sub 1, y sub 1, and x sub 2, y sub 2 is given by the following formula. So the same picture that you see here, if we want to know the distance from this point to this point, how long is that? We could use this formula. So some more symbols. What does this little triangle mean? Well, it's pronounced delta. It's a Greek letter, and it means the change in. So it means you subtract your x values. What's delta y mean? It means you subtract your y values. Subtract your x values and square it, plus subtract your y values and square it. Take the square root of that, and that's going to be the distance between the 2 points. Let's look at some real examples. Real meaning not real life. Let's not get carried away. Real examples from our notes, people. Come on, pay attention. Now, let me give you the formula for success for geometry. People will resist it, and as long as you resist it, you will not be successful. And when you're not successful, you're going to get frustrated. When you get frustrated, you're going to tell your parents what a horrible person your teacher is. Then your parent calls me and chews me out, and then I get depressed and I start drinking Pepsi all the time. So if you don't follow directions here and do as I say, I'm going to continue my quest for a scorching case of diabetes. In general, to do these problems, 1, you read the problem. That's obvious. 2, you draw a picture. 3, you put the information from the problem into the picture. 4, you make an equation from the picture. 5, you solve the equation. 6, you answer the question. Now, it sounds like a lot. It isn't. For example, in this first one, hey, the picture's already there. And reading the problem goes without saying, so we just eliminated 2 steps. So let's read the problem. Given O is the midpoint of segment DG. Now, is that information, O is the midpoint of segment DG, is that currently in the picture? It is not. It shows that O is between D and G. It does not show it's the midpoint. To show it's the midpoint, we put the same number of dashes on either side of the O. Now the picture now shows that segment DO is congruent to segment OG. Next part, it says DO is 6x minus 7. That's not on the picture yet. We're going to add that to the picture. This is 6x minus 7. OG, from O to G, is 5x plus 1. Let's put it onto the picture. We read the problem. Picture was already drawn. We put all this information into the picture. So that means the information in the problem now is now useless to us. We only focus on the picture. What does the question ask? It says find the length of DO. Most of the time, I would encourage you to ignore the question initially. Because if you focus on the question, you might find yourself saying, I don't have any idea how to find DO. That's fine. You don't have to know how to find DO. What you do have to know how to do, I'm separating my work. I'm going to have work here and work here. We need to be able to take this information and write an equation from it. Now, according to the definition of midpoint, which says if M is the midpoint of segment PQ, in this case, if O is the midpoint of segment DG, then O is the point between D and G such that DO is equal to OG. We're looking for an equation. We have it. DO is equal to OG. When you make these equations, if there are letters in the picture, you first make the equation with the letters. Trust me, as annoying as that sounds, when we do the hardest thing that you've ever done before in any class, which are called proofs, this is going to help you. So we want to practice doing this now. So when we get to proofs, our minds are not blown away. Literally. Once you have an equation, which we clearly do, DO is equal to OG because O is the midpoint, you then replace whatever the length of DO is, it's 6x minus 7. We would call this the substitution property of equality. We're going to replace OG with 5x plus 1. We would call this the substitution property of equality. Why is it called a property of equality? We're using an equation. Technically, it's the substitution property of equality for real numbers, because this represents real numbers. From here, it's algebra 1. And I'm assuming you are gangbusters at algebra 1. So, sum up, draw the picture, put the information into the picture, make an equation, solve the equation. So let's solve this equation. I'm going to subtract 5x from both sides. Now, if you're the type of person that wants to put minus 5x, cool. If you're the type of person that wants to say, we're going to separate this, the left and the right side, not cool. We don't do that. It was great to do that at the beginning when you're learning algebra. Don't do that. We're going to write it in a mature way, which is mathematically correct. Once again, the minus 5x's, I can live with that. I cannot live with you drawing the squiggly line down through the middle. That's something that you've been doing. That's a habit that you need to break. I insist. Then we're going to add 7 to both sides of the equation, and we get x is 8. Now, once again, if you're the type of person that wants to put plus 7, I'm fine with that. Before we continue, everything we do in geometry, we have to be able to give a reason that we can do it. And the reasons I'm going to give for this stuff we just did in this, the stuff you learned in algebra that you may have forgotten. To go from here to here, we use the subtraction property of equality for real numbers, which says you can subtract the same thing from both sides of an equation anytime you want. From here to here, we use the addition property of equality for real numbers, which says we can add the same number to both sides of an equation anytime we wish. Once you know what x is, then try to answer the question, which we have not addressed. Find the length of DO. Well, according to our picture, DO is equal to 6x minus 7. According to our work, we know what x is. It's 8. Using the substitution property of equality, I'm going to replace x with 8. 6 times 8 is 48. Subtract 7 from that, and you get 41. The length of DO, if you will, is 41. This is a great representation of what this class is. Some students have a hard time catching on to this. However, all students catch on to this. Everyone, even you. Number 2, there's no picture for this. This is going to be more complicated. Segment JM bisects segment AX at M. Well, we got this word bisects. It's an important word. It's a word we just learned today. And when we learned it today, it was actually called a segment bisector. Here it just uses the word bisects. Anytime you have a bisector, draw what's being bisected, what's being cut in half first. So I'm going to draw segment AX first. Now it says segment JM bisects this at M. Here's what that tells me. M has to be on segment AX. Specifically, M has to be the midpoint. J could be up here someplace or down here someplace. It doesn't make a difference. It's a segment. Now let's see if this represents what this picture shows or what the words say. Segment JM, I have segment JM. Bisects, goes through the midpoint. Segment AX, here's segment AX, and it does it at point M. Boom. If you would like to put these big dots at the end of your segments, feel free to do so. It's not necessary. We now have a picture, and we were given this from this first sentence. Second sentence, the length of AM is 2x plus 45. I'm going to put that right here. The length of MX is 3x plus 30. I'm going to put this right here. Find the length of MX. Let's not worry about what the question's asking right now. Let's focus on making an equation. Our picture clearly shows that M is the midpoint because segment AM is congruent to segment MX. Therefore, AM is going to equal MX. Once we have our equation, let's substitute using the substitution property of equality. We're going to replace AM with 2x plus 45. We're going to replace MX with 3x plus 30. Using the power of algebra, we're going to get x by itself. Going to subtract 2x from both sides. That's a subtraction property of equality for real numbers. Going to subtract 30 from both sides. That's a subtraction property of equality for real numbers. So now we know x is 15. Question doesn't ask for x, it asks for the length of mx. Mx, according to our picture, is 3x plus 30. Since we know x is 15, we can substitute it in. And we're going to find that this is 75. That answers the question. All right, number 3. Find the midpoint and length of segment AB. Now this is an easy version of this problem. Well, let me show you why. A is to the, you start at the origin. These are coordinates. This says left, -5 says go left or right. Since it's negative, you go left. This 3 says you go up 3. So we start at the origin. We go left, 1, 2, 3, 4, 5. Then we go up 3, 1, 2, 3. That puts us right here. B says you go left 1 and up 3. That puts us right here. Now, if you're lucky enough, that's why this is an easy problem, that your segment is vertical or horizontal, and you want to find the midpoint or the length, you just count spaces. Let's not get crazy. Let's do the length first. The length from A to B. Start at 0, 1, 2, 3, 4. Well, the length of AB is 4. There's really no work to even show. What's the midpoint of this segment? Well, halfway between, if we went from here to here was 4, it would be 2. And those coordinates would be left 1, 2, 3, and up 3. Easy. Easy, easy, easy. Well, let's check out number 4. Not as easy if it's not vertical or horizontal. C is -6, -5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That puts us here. D is 7, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. That puts us here. We want to know where the midpoint is and what the length of the segment is. Can't count spaces because in the diagonal, like if I count diagonally, that's not a unit of 1. This is 1, this is 1. Who knows how long that is? Using the midpoint formula. Every time you use the midpoint formula, you must write it out first. What if you don't want to write it out? Well, this is America. You don't have to. But I'm also an American, which means I can choose not to give you full credit for the problem if you choose not to write it out. So let's sum our x values together. We have a -6 and 7. What's the sum of -6 and 7? Well, that's 1. What's the sum of -5 and 3? Well, that's -2. If your fraction can be reduced, reduce it. 1 over 2 doesn't reduce. -2 over +2 reduces to -1. So the midpoint of CD is the ordered pair. Midpoint of segment CD is the ordered pair 1/2 -1. CD, to find this length, we're going to use the distance formula, which says we subtract the x values, then square it. We subtract the y values and then square it. If I take these x values and I subtract them, I'm going to write this out because subtraction is much more difficult than addition. -6 minus 7 squared, and I'm going to have -5 minus 3 quantity squared. -6 minus 7, that's a -13. -5 minus 3 is -8. Now it's important that you leave these brackets around this because we are squaring the -13. I'll show you in a moment why that's important. A -13 squared is 169, and -8 squared is 64. If you add those two fellas together, you get the square root of 233. For the time being, if this is a perfect square root it. If it's not, we'll just leave it as an exact answer. So, sorry to do this to you, but it needs to be addressed. This could never equal this. What's the difference? This one says square 13. When you're finished, make it negative. This answer is a -169. This one says take a -13 and multiply it by itself. If you multiply two negatives, you get a positive. This is a negative answer. This is a positive answer. They are wildly different. All right, number 5, last one. Segment ME has the endpoints of M and E. Find the midpoint of length of ME. Well, I feel like we just did this, but this doesn't give us a picture. We don't have to have a picture for this. So let's do this. We got the midpoint of segment ME. Every time we use the midpoint formula, we're going to write it down. What's the sum of the x values? What's negative 6 plus 1? I'm sorry, what's negative 6 plus 5? That's a negative 1 divided by 2. What's the sum of the y values? 4 and negative 2 is negative 2 divided by 2. It's going to be negative 1/2, negative 1. Very similar to the previous answer, weirdly. Let's find the length of ME. You can use the distance formula. Difference of the x values squared plus the difference of the y values squared. Our x values go negative 6 minus 5. Our y values go 4 minus a negative 2. This is negative 11 squared. Until you square it, leave it in parentheses or brackets. 4 minus a negative 2 is like 4 plus 2, which is 6. Negative 11 squared is 121. 6 squared is 36. That's going to give us the square root of 157. All right, that concludes our second day of notes. Check out the website for the assignment.